In today's episode, you'll see a Chinese machine that generates forces up to 1,900 times Earth's gravity, among other things, letting scientists watch in minutes what would take centuries to occur. Bill Gates has permanently put food into the technology debate. He wants us, human beings, to be able to eat artificial meat. The emergence of Neuro-Rights, an attempt to protect the human brain, as neural interfaces, the head chips, are moving from science fiction to reality. Mass production of humanoid robots in China is accelerating. Agibot has presented 5,000 units, and robotics is starting to get closer to the human body in order to enhance our abilities and rethink our relationship between technology and autonomy. Let's understand all of this. 3. For years, heavy electric transportation seemed unfeasible, not because of a lack of engines, but because of something basic. However, over time, this has changed. Tesla released real footage of the Tesla Semi being charged at a maximum power of 1.2 megawatts, a number that until recently only existed in slide presentations. The video shows the truck connected to a megacharger, as the power gradually rises to a level almost 5 times higher than the fastest regular electric car chargers here in North America. For a truck with an estimated range of up to 800 kilometers and a battery that can reach up to 850 kilowatt-hours, this means recovering most of the charge in less than an hour. In practice, charging aligns more with real rest time and digital logistics. The secret lies in Tesla's V4 architecture, designed to operate between 400 and 1,000 volts, combined with liquid-cooled cables and connectors with advanced thermal control. It's heavy engineering, solving a heavy problem. Unfortunately, Tesla still hasn't shown the complete charging curve, meaning how long the Semi can sustain that maximum power. But the message is already clear. The main bottleneck in long-distance electric transportation is easing. And as transportation evolves, everything it moves is reconsidered. For example, for Uncle Bill Gates, the problem isn't with the vehicles, it's with our plates. Yeah, the billionaire businessman argues that traditional cattle farming needs to be replaced, especially in wealthy countries, by plant-based alternatives or artificial meat. According to him, the main reason is methane, a gas with a warming potential 86 times greater than carbon monoxide, too. In the short term, some studies say it is mainly released by the management system. Yeah, I know, the topic is quite controversial and doesn't necessarily reflect my opinion on it. Here, I'm just the messenger. Remember, don't attack me in the comments. Bill Gates cites data showing cows produce about 6% of global methane emissions. While this may seem small, it's significant on a global scale. Reducing the herd would lower emissions and ease pressure on farmland, water use, and related environmental impacts. Their bet is on companies like Impulsivo Foods and Beyond Meat, which use plant-based proteins and industrial processes to simulate flavor. We're going to eat meat that tastes like meat, but it's not real meat anymore. Wow, even I'm falling for these things. That's a meme, right? Well, let's go. Besides simulating the texture and appearance of traditional meat, I doubt it will ever look like the barbecue I like so much. Bill Gates says these alternatives can be much more sustainable and even a bit healthier by reducing cholesterol and metabolic impacts. But the proposal is divisive. Countries like ours with strong agricultural economies see it as a threat to food security and rural income. Supporters note that the current model faces growing climate pressure. The main issue is not consensus. It's the fact that food has officially entered the technological debate. And when even our food starts to be, in quotes, okay, recreated, it becomes clear that we're not just optimizing processes and automating many things. We're trying to redesign the physical boundaries of our planet, which explains why, on the other side of the world, scientists decided to experiment with something even more fundamental: gravity itself. At Zhejiang University in eastern China, a machine has just exceeded a limit that was once thought to be only theoretical. Named TIF 1900, this hypergravity centrifuge can generate forces up to 1,900 times Earth's gravity. To give you an idea of the scale, a regular washing machine reaches about 2 tons of G-force. Here, we're talking about almost 2,000 tons. In practice, this means accelerating natural phenomena that would normally take decades, centuries, or even thousands of years. All this condensed into minutes or hours of experimentation allows us to observe what once required waiting for time to act almost instantly. The researchers' own example highlights the simulation's quality. A 3-meter-high dam model exposed to 100 G can simulate the structural behavior of a real 300-meter dam. Failures, deformations, collapses, even earthquakes, all of this can be studied in detail without real risks. But the use of the TIF 1900 goes far beyond large-scale projects. The machine can also analyze how high-speed train tracks resonate over time, how pollutants seep into the soil over thousands of years, or even how materials degrade under extreme continuous stress. All of this happens inside a robust centrifuge, which is similar to those used to train military pilots under high G-forces, just on a completely different scale. Here, the challenge is not just spinning fast, but also managing extreme heat, vibration, and stability. The engineers developed a new advanced thermal control system using environmental and vacuum conditions, integrating liquid cooling and forced ventilation. Without this, the friction and heat would destroy the equipment. According to the project's chief scientist, the goal is ambitious: to create experimental environments that span milliseconds to thousands of years and atomic scale to kilometers, under both normal and extreme temperature and pressure conditions. In other words, Chinese science is not just trying to understand our world or how it is trying to recreate how the world behaves over time. This happens much faster. When does science begin to speed up time? It's not just testing materials, it's testing the very limits of human intervention in nature. This principle of accelerating processes is now being applied to our bodies too. Robotics in the human body has mostly focused on factories and industrial efficiency, but now a quiet shift is starting. The human body has become a central part of the technological equation. And this is where ADEV comes in, a company created out of a real need. One of its founders has used a wheelchair since birth, and it was exactly this experience that turned an academic project into something much bigger, applying robotics and artificial intelligence directly to physical rehabilitation. Reflex is the main result, a lightweight, just over 2 kg robotic device that attaches to the leg to aid orthopedic knee rehabilitation. But it's not just passive, okay? The system uses sensors, remote monitoring, and software-guided exercises to enable longer, more consistent sessions than those with only a human physical therapist. Maybe the most important point of this approach is philosophical. Unlike industrial robotics, this machine adapts to humans, learns from their limits, matches their pace, and enhances their abilities instead of replacing them. Robotics stops being a spectacle. It now becomes an extension of our body. When technology physically merges with humans, an inevitable question emerges: who protects the mind once the body is connected? Human privacy has always been tied to the body, home, communications, and personal data. For the first time, a new frontier is emerging that has never needed formal protection. The brain itself, our minds, with the advancement of neurotechnologies, brain-computer interfaces, are no longer science fiction. We've been seeing this here on the channel for quite some time now, haven't we? Today, this technology already allows paralyzed people to move cursors, write texts, and interact with machines using only their thoughts. Other research goes even further, decoding neural patterns linked to emotions, intentions, and even mental images. The problem is that, while these technologies do restore lost abilities, they also create an unprecedented risk. Thoughts, impulses, and mental states become data that can be collected, analyzed, and used externally, which is quite dangerous. And it's in this context that the so-called Neuro-Rights emerge, which are basically a set of human rights aimed at protecting cognitive freedom, our mental privacy, and also the integrity of personal identity. The idea is simple and at the same time profound. No one should have access to, control over, or interfere with another person's brain activity or assets without absolute consent. This debate is just beginning, with only a few bills in Congress, including in ours. In Brazil, they're still trying to define them. How should neural data be protected? And what limits should be set on neurotechnology use? Some proposals go further and argue that these rights should be incorporated directly into the Constitution, recognizing the human mind as an inviolable part of one's personality. And the warning doesn't come only from the legislative branch. International organizations, universities, and ethics experts point out that neural data is different from any other type of sensitive information. They don't just reveal what we do, they can reveal who we are, what we feel, and even what we haven't expressed yet. Without clear regulation, it opens up the possibility of a future where companies, governments, or automated systems have direct access to the last truly private space of the human being. Neuro-Rights aren't about halting technology entirely, we hope not, since technology is vital and offers many benefits, but it's about preventing technical advances from surpassing mental autonomy before our society even realizes it. When, my friends, does the brain become exploitable? We're not just discussing innovation anymore, we're talking about who controls the mind in a world where thinking is visible. Although algorithms have already been doing something very similar to us without putting any chip in our heads. All right, be careful with that. International organizations like the Organization for Economic Cooperation and Development, United Nations Educational, Scientific, and Cultural Organization, and the Organization of American States are already publishing recommendations, and countries like Chile and even our own Brazil have made some progress in legislation. The consensus among researchers is very clear. Waiting for abuses to happen before regulating may be too late. Some countries aim to protect the brain, while others push for physically replacing human labor in a similar direction. Agibot has reached 7,500 mass-produced humanoid robots, significantly changing the conversation. The company, based in Lingyang, Shanghai, is not focused on isolated demonstrations. It runs a factory collecting real-world data, where robots continuously train on tasks like folding clothes, cleaning, and handling delicate objects. These aren't simulations, they're real scenarios happening thousands of times daily. The company's models, such as Rise A1 and Yangtze Hong A2, have up to 49 degrees of freedom, which allows for extremely precise movements, from tightening screws to threading a needle. But the difference is in both the body and the method. Agibot relies on learning guided by physical data, something that is essential to turn robots into reliable workers. While many companies are still trying to prove that humanoids can work, China is tackling another question: how to scale all of this. Agibot's initial focus isn't on homes or unpredictable environments, but on structured sectors like manufacturing and logistics, where tasks are repetitive, measurable, and economically justifiable. There's also a demographic factor behind this acceleration. With a rapidly aging population and labor shortages in several areas, humanoids have shifted from a luxury to a strategic necessity for them. The goal is clear: to achieve human-like efficiency at a cost that makes economic sense. The result is a silent yet profound change. China is not just creating better robots, it is building a complete supply chain to build and also maintain these humanoid robots, integrating motion control, artificial intelligence, and large-scale production. It's here. The robot is now part of the production chain, not just a tech showcase. And when machines take over factories, kitchens, and all kinds of services, even the way we get around starts to change. Check this out. Here, the discussion about the future of mobility revolved around an almost utopian promise. Autonomous cars would bring people closer together, reduce costs, and make transportation much more efficient through sharing. The idea was that we would call a car through an app and share all these experiences. But the startup Plit is emerging by going in exactly the opposite direction. Based in California, they recently introduced an autonomous taxi that wasn't designed to share experiences. It was actually designed to eliminate them. The vehicle is divided into 4 completely independent capsules, each functioning as a private space on wheels. There's no eye contact, forced conversation, or awkwardness. Each passenger has their own microenvironment. The idea is simple but revealing. Let me show you something interesting. If technology can optimize routes, why not reduce human discomfort too? The capsules have one-way glass, insulation, sound control, and individual controls. You can see outside, but the world can't see you, and there's more. If that's not wanted, internal screens provide entertainment, work, or distraction. Plit calls this modular privacy, the ability to choose how much you want to exist socially during a trip. If you want company, well, if someone else wants it too. The divider lowers, and for complete silence, keep everything closed. The zero-gravity-inspired seats also focus on rest and isolation. And you can see that this project isn't just about mobility. It's about society, about a world that's increasingly connected and, at the same time, increasingly fragmented, where technology isn't being used to bring us together, but rather to fragment society even more. Technology isn't the issue, Most people dislike crowded buses, where everyone is squeezed together and bump into each other whenever the driver brakes. But when the transportation of the future is designed to avoid interaction, when control is directly linked to isolation, and when even daily commuting becomes a space for escape. Maybe the much more important question isn't where we're going, but who we're trying to get away from. Even when we're surrounded by people, each on their own phone, we're together in the same circle but not talking or even making eye contact. It's clear, my friends, we see impressive advances every week. And the same technology that creates incredible gravity machines, for example, is also the one that helps someone walk again, move, and even live better. Maybe the future isn't about machines replacing people, except for a few cases, of course, but rather about technology finally being used to benefit our lives, the lives of human beings. Which of the innovations in this episode gave you more hope or made you more worried? Use the comment section here. That way you help me out, okay? YouTube starts promoting the video more, people start interacting with it more, and you get new videos here from Rehabilitation. Impressive. Thank you very much for sticking with me until now. Choose one of the two options on your screen. See you next time. Thanks. Bye.